Hello all, welcome back. We're going to look at merge sort now. On the board you can see an example, an unsorted array, and we're going to sort it using merge sort. So merge sort is going to be implemented using a recursive algorithm. But in practice, this recursive algorithm will obviously, as we have been explaining, should be converted into a non-recursive procedure. If you want to implement this in practice, you will have to do that. But it's easier to understand the recursive algorithm and also to analyze, etc. Right, now so here is an example, an unsorted array, and so the main idea is the following. We're going to split the array into two equal halves. Okay, so right now there are 8 elements, so therefore we are going to split it into two parts, 4 for each. Obviously, so you can ask what happens if it's an odd number. If it was 9, you would have split it into 5 and 4. Okay, it's as right now. So you split it into two parts and you do the following. So how do we split? You split it in the middle, right? So you're going to split it in the middle of this array. You're going to split it into two parts and you're going to sort this part and you're going to sort this part separately. You first sort this part and then you sort this part, right? So first let's do that. And how are you going to sort this part? Do you know sorting method? Yeah, you know merge sort. So you're going to recursively call this thing. You're going to recursively sort this part and you're going to recursively sort this part. Once you have sorted this part and you have sorted this part, then comes what is called as a merge procedure. Okay, so let's do that. Let's go one by one, and I'm going to assume that the recursively merge sort has given me a sorted array of this. Okay, so this part has been sorted and also it has sorted this part. So I'm going to write those two parts. Okay, so there are two parts. The first part, it has sorted this side, so the sorted array will be 1, 5, 7, 9, right? This part will be sorted as 1, 7, 5, 9, and the other side you're going to sort this part. And how will it be sorted? So it will be 2, 5, 6, 8, right? So these are sorted. And is it clear? Okay, so obviously I'm not explaining to you how this was sorted, right? Because I want to first tell you how the merging function is going to happen, and then we will take another example where we go through it in more detail. Okay, so let's just assume that someone has given me a sorted, so this side someone has given me someone has basically sorted the first half and someone has sorted the second half. Now if I'm given basically two sorts, can I make a combined sorted array? Can I do that? That's the question we are asking. How can I do this? Right, so to do this, this is the procedure which is called as merge. Okay, and so to merge, the idea is simple. So you're going to keep two pointers here. Okay, so this is, let's call it the pointer I, and this is pointer j. Okay, you have now two pointers I and j, and what is it you do? Just assume that you have a new array. Okay, I'm going to have a new array here. Okay, again 8 elements, a new array, and we have two pointers I and j pointing to these two locations. And what does it do? First, I'm going to compare ai and aj. Okay, so these two numbers we are going to compare. Which is smaller? Smaller is this I. So I'm going to write the smaller value here, 1. Then what do? I shift my I one step to right. Okay, I shifted only I. Why did I shift I? Because this was the smaller array. Okay, so I just shift this. I shifted I here, and now this is my I. Okay, Next, what do I do again? I'm going to just compare again this part, this point and this point. It's 5 and 2. Which is smaller? This is j is smaller, 2 is smaller. So I note down 2 here and then I increment j. So j comes to that. Next, again, I'm going to compare AI and AJ, and it turns out both are the same. So you pick, let's say you're going to pick I. When they are same, you're going to pick I, and so therefore you just increment here. Okay. And you copy this 5 here. Okay. Now you compare this I and j, and you see this 5 is lesser, so you move here, you write down 5 and you move to this place. Right? Okay. Next, you compare 6 and 8, you realize 6 is lesser, copy 6 here and you move right. Okay. Next is you compare 7 and 8 and you move 7. Finally, you compare 8 and 9. And you chose 8, and then this j is out. Okay, so j has now moved out. And so now that's it, over. J is not going to play anything. Now whatever is remaining here in this array, we're going to copy here. So right now there's only one element, so we just copy that. Okay, this is merge sort. So as you can see, the array here on top is a sorted version of this array, right? Okay, this is a sorted version of this array, and we got it because we have merged these. So this is a merge procedure. So we merged two arrays, this and this. Okay, so what is the input to a merge function? The merge function, what is the input? The input is two sorted arrays, this one and this one. So that's the merge function. It's two sorted array, and we are just combining them together. Okay. Right, now let's we can write the merge function now. Shall we do that? Okay, we can write the function to merge, and then we will just use the merge function later. And we will write the merge function assuming these two matrices are of the same size. Otherwise, as we said, if this is of size 5 and this is 4, we'll have to just do a little more work. But we'll have to pass two parameters saying the size of these functions. So we'll just keep it simple. Okay, so I'm going to have a merge function. So merge, what does it do? It's going to take two arrays, right? Int, so AR1, so two arrays, and they are going to have, as we said, same size, int, let's say n. Okay, and then we should also pass it a third array, which is int, which is going to be the return array. So array f arf for array final. Okay, this is the array which is going to be returned, the copied array we saw. Okay, now right, and let's now write the merge function. So for merge functions, obviously we need to have two pointers, right? So let's just define that, since we know we need to have two pointers. Int I is equal to 0, j is equal to 0, and also we should also keep a pointer to keep track of where to place each of the elements in the new array ARF. Okay, so that will be k0. Okay, so these are our 3 indices I, j, and k for each of the three arrays. Once I have this, what is the next thing I'm going to do? I'm going to go through So I'm going to write a while loop. Okay, and what is a while loop I'm going to write? So I'm going to write that so I has to be less than n. Okay, once I becomes n, it means that we have crossed the matrix. So we have crossed the array here, right? And so while I is less than n, so and so j is less than n. So this is I mean our Boolean and in C you would have written with 2 ampersand symbol. Okay, so while I is less than n and j is less than n, so while both are less than n, what is it we have to do? We're going to compare both of them. So if AR of I is less than AR of j, what is it we have to do? We have to copy the lower one into the new array, right? And so this is this. So okay, AR1 of I and AR2 of j, right? In this is the case, I'm going to copy the smaller one into the new array. So okay. Okay, so if AR1 of I is less than or equal to AR2 of j, I copy AR1 of I to ARF of k. Otherwise, I copy the other element. Okay, and then once you are here, okay, you have to do one more thing. So if you did this, you will have to do I is equal to I plus 1. On the other hand, if you did this, you will have to do a j equal to j plus 1. And obviously, you will have to do increment k. So this is the end of the while loop. Okay. Now once this while loop, you come out of the while loop, what has happened? When you come out of the while loop, it means that either I has crossed, has reached n. So that is either I has reached here or j has reached here, right? It's moved out. So one has reached outside means the other, so there's one remaining, right? So if there's one remaining which is inside, we'll have to just keep on copying that part um, into the array. So let's assume that I is outside. So we'll do one more while loop. So while, or let me write a for loop for uh, so I'm going to go through I. Okay, so I'm not going to change the value of I, so that we'll just leave it whatever I is right now, and then I'm going to write I is less than n. Okay, so the current value of I, so this is left blank to mean that I'm not changing the value of I which I got from here. If this is the case, and what does it I do? I just do, okay, I'm also going to increment k plus plus. Okay, okay, let's not complicate it. So I'm going to write AR. Okay, so I just copy all the remaining things in the first array into the final array, and then you also need to have a similar statement here below, which is about copying AR2. Right? If AR2 is less than n, you have to copy that into this array. So you need to write another function. So I'm skipping that. So there's one. So let me just note down here. Also add code for copying Okay, so whatever is remaining in AR2, so whatever is remaining in AR2 also you need to add a for loop for copying that also. So I'm skipping that, but you know how to do it because it's just symmetric to this. Okay, so this is merge. Now once you merge, you're going to get the final array into this array called, so the sorted array into ARF, right? So this is merge sort. Now let me go into detail in how this will be executed in completely, how merge sort is going to execute this fully, right? So let's do that, and then we will understand it, and then we will try to analyze it, and then finally we are going to write the merge sort. Okay, where we will use this merge function. Okay, so this is our array, right? So this is our array, two arrays. What we do is that when I'm calling, so this is, so you will be using merge sort of this. This is how you're going to call it, right? Merge sort of this array. This is how your function, that merge sort function will be invoked with this array. You're going to split this array into two halves, and you're going to call merge sort with this half, and then you're going to call merge sort with this half. So first you're going to call merge sort with this half. So let's try to work out what happens there. Okay, so we're going to call merge sort with this array, and what happens if we call merge sort again? So merge sort is going to split this array again into two. Okay, and let's see what happens there. Okay, now once you have reached two stage array, uh, when there are like two elements in the array, what does it you have to do? You can you just sort it, right? You just compare that. So I mean, you can also think of merge sort calling this again and make it into two, one element each, but let's just keep this as the base case. So you have two element array, and what is it you need to do? You sort it here, right? Okay, so you're going to sort this into 5 and 7. So this is what, so you sort that into 5 and 7. Okay, and then you sort this also into 1 and 9. Okay, okay, now, so this is 5 7. Okay, okay, so 5 7 and 1 9. These are sorted arrays. So what should it do? We are going to call merge again to sort these two things. Okay, so we call merge sort, merge function to sort, to merge these two sorted arrays and there. Okay, so if we merge these two arrays, what happens? So this is going to be 1 9 or 1 5 7 9. Okay, so that's merge function going to happen there. So in this case, we are going to actually fill it into a new array, right? So the return is going to be in a new array, but let's just copy it here. You can think of this as a new array here. Okay, so I am merging these two arrays, and this becomes 1 5 7 9. Okay, this is, we are actually returning going back. Now, Now merge sort here gets this sorted array. So merge sort now calls this part of the array, and let's okay. So this part of the array is now 2, 6, 5, 8, and merge sort splits this again also into 2, 6 and 5, 8, and then sorts these things. So this is already sorted, this is also already sorted. So it's going to merge them, and when they merge it, we are going to get 2, 5, 6, 8. Okay. So now we have two sorted arrays. Okay. So now we have two sorted arrays, this one and this one, and merge is going to, this function merge will merge these two and get a sorted array just like we saw earlier, right? Okay, so this is merge sort. Now let me, so now comes the question. So I hope this is fine, right? Question is, now we need to analyze the running time of merge sort. Let's first do that and then we write merge sort. How do I analyze? So every time, you can think of every time the merge sort splits these two into two halves. Okay, and then work on that, right? So merging, so once it is split into two halves, let's say you get these two parts, the sorted array, and then there is some work involved to merge. How much time is taken to merge? Right, so the time taken to merge is basically this function, and we can just check how much time is taken to merge. This while loop runs for like n times or order n times, right? Because it's how big can k become? K can become at most 2n, and right, because k is going to be the sorted array of it's a merge of both these arrays, each of size n. So ARF can be a array of size 2k, sorry 2n. So k can at most become 2n, and every time, every step of this while loop, k increases by 1, right? K starts from 0, k increases by 1, and every iteration here also k increases by 1, and in the next for loop also k increases by 1. So after 2n steps, we are done. K would have reached the final position of 2n, and then we would have done. So what is the run? So how many steps did this execute? Some constants into 2n steps was executed, and therefore the running time of this merge sort is order n. Okay, right. So this is order n. That is the main point we are trying to make. Okay, where n is the size of the array. Okay, and now let's so once we have this understanding, we can now, so merging takes order n time. That's the crucial point. And then we can now try to analyze merge sort using this idea. Okay. So I'm going to rub this thing off, and then we are going to analyze merge sort here. Okay. So what happens in merge sort? You have a huge array here. Okay. Let's say it is of size n. Okay. This n is not this n. This is the n for merge sort. Okay. This function. Now, so I'm going to assume that this is an array of size n. We need to do a merge sort. And what happens? What does merge sort do? Merge sort is going to split it into two parts. Each of size n by 2. So I'm going to note down this here. Each of size n by 2, right? And then it keeps again splits it again into two parts. Each of size n by 4, right? And how long does this continue? Finally, you reach, so let's say finally it reaches on one element array. It's easier to explain now. So at every height, so every height we are dividing the array size by 2, right? So if h is the height, so can you tell me what is h depending on n? Okay, so, see, with one edge, one drop, this is kind of things we have analyzed. So with one edge, each of the array size has become n by 2. With one more edge, array size has become n by 4. And how many? What will be the height of this tree? Is the question. Right? We know the answer. This is a complete binary tree, right? This is a complete binary tree, and its height is we know that. So height is going to be order log n, right? Height is the exact height is log n plus 1 minus 1 or something like that. So I'm going to write it as height is order log n. Okay, so this is the height of this tree. Okay, now so there are this many levels. The number of levels is order log n, right? Okay. Now comes the next question. At each level, how many how much computation do we do? So at each level you can see there are a lot of merging happening, right? So there is one merge happens here. So you merge these two, then you merge these two, you merge these two. So similarly you're going to merge. So there's going to be a lot of merge in every node in the tree. So let's come how much time is spent to merge these two. So this is of size n by 2. We know this fact. This is n by 2 and this is n by 2. How much time to merge n by 2 elements? Okay, we know this is going to take n time, right? Okay, this is something we saw here. This is going to take n steps, some constant into n. So let's call it n. Okay, if you want, we can say it's some constant c times n. C times n steps were taken here to do the merge operation, right? And so here in this thing it's n by 4 and n by 4. You do a merge on these two things. If you're going to merge these two, how much time is taking? It's c times n by 2, right? Here it took c times n, where n is the size of these two combined array, and here it's c times n by 2 because n by 2 is the size of this combined array. Okay, so this is c times n by 2, and what about this? This is also going to take c times n by 2. So this is c times n by 2, n by 4 plus c times n by 2 plus c times n by 2. Okay, this turns out to be c times n again. Okay, now I'm going to claim that at every point in every position here, the number of computation time spent is Cn. Okay, this is something you should go and check at a height I. Let's say this is height I. Okay, how many nodes are there? These are all given by our tree, right? How many nodes are there and how much time will be spent there. Okay, at that level, and that's going to turn out to be Cn. But you can also look at the last point. So last point, there are how many nodes? There will be n nodes, right? And you can assume that that's also going to take Cn. I mean, it's bounded by Cn. So even though you don't do anything, you can just say it is less than or equal to Cn there also. So now, the point I'm trying to make is that at each level you're going to spend some Cn time. And how many levels are there? Log n levels. So what is the total time you spend to do merge sort? Cn into log n, order log n, right? So do you see what I'm trying to say? I'm trying to say that merge sort takes so Cn into order log n, Cn into order log n time, and therefore this is equal to order. This is therefore the running time of merge sort. Okay. I hope this is it's clear to you what is happening here. We'll now write the merge sort algorithm. Okay, intent and an extra array where we are going to output our results. Okay, now what is it we are going to do? We are going to first split the array into two parts, right? So I'm going to, let's say, okay, I'm going to, so to make our life easier and to see how things work easier, what I'm going to do is the following. I'm going to create two new arrays. So let me call it AR1 and AR1. So this will involve some copying from AR array. I'm going to copy from 0 to elements from 0 to n by 2. I'm going to copy into this new array AR1. But this is not C syntax as such what I'm writing. This is you'll have to convert it into C if you are writing it into C program. Now similarly, I'm going to copy AR2. Okay, this is we have now two arrays AR1 and AR2, right? And we are also going to create two the output arrays BR1 and BR2. Okay, we need to create these things. So that is allocates memory space. Right. Once we have this, what is it I'm going to do? I'm going to call merge sort recursively on this and this. Okay, so okay, so what happens? AR1, we're going to call merge sort on AR1 and this is n by 2, sorry. And we pass on BR1 where it is copied. The sorted array is now copied into BR1. Similarly, again AR2 is passed and its sorted array is copied into BR2. Then we are going to merge. We're going to merge these two arrays. Oh, so this has to be BR1. Okay, we have we merge the arrays BR1 and BR2 now and copy the merged array into the array BR. This is merge sort, but we have to, so this is merge sort with the recursive step we have it. So this is a recursive algorithm. So we didn't write the base case. So what is the base case? So base case is we are allowed to take care of here. If if n is equal to 1, what does it have to do? So if the size of n is 1, AR is same as BR, so you'll have to copy it into AR into BR, right? Sorry. So if n is equal to 1, there's only one element in the array, so there's nothing to solve. So since output is a BR array, you just copy what is in AR to there. So I'm not going to write what needs to be done. And similarly, if n is equal to 2, because we had our base case to be n is equal to 2, so if that is the base case, we write if n is equal to 2, what needs to be done in the two case situation. We just compare the two elements and then copy the smaller one first into BR and then the second most smaller one. Okay, that's it. This is merge sort. Right. Okay, so now we saw its running time. Its running time is order n log n. But another important question to ask is, what is the space, extra space it takes? Is it order 1? No, the extra space is too much because we are creating BR1, BR2, which is same size as AR1, right? So the extra space, so in this situation, the extra space turns out to be order n log n, right? Because at every iteration, I am creating n space, and then we know that there are that much that many nodes, right? So the height is log n. So therefore, you're creating n log n extra space. So the space complexity of this algorithm is n log n. Therefore, okay. So now we have merge sort, and so merge sort that way, but it's much faster than our simpler sorting algorithms we saw till now, because it's now the worst case running time of n log n. That's the most important point. Even in the worst case, it takes n log n. And the amazing thing is that even in the best case, it's going to take n log n. Okay, so merge sort, even if you take a fully sorted array. So what was the best case in our previous sorting algorithm of let's say bubble sort? What is the best case scenario for bubble sort? It was order n, right? But merge sort, even the best case is going to take order n log n. That's because it has to go through this entire tree in the best case also, and therefore it's going to take order n log n in the best case and in the worst case, and in average case merge sort is order n log n. Okay, and right, and this is not in place because as you can see, it's going to take an extra space of order n log n. Okay. Thank you.